Okay, let's restart. Okay, well, welcome everyone to our SIAG SC outreach event. This is, maybe I should share my slide for this event. This is first out of the three sessions that we will be doing. This one is the one on May 12th for the Africa, Asia, Europe time slot. We will have two more, and so each session will have a lightning speaker and a 5 to 10 minute talk, and then we will move on to some discussions of how we can do SIAG-SC worldwide outreach. And so let me introduce our first speaker. So today we have Sadaf Alam from CSCS. She is currently the CTO of CSCS, and in her role as CTO, she ensures the end-to-end integrity of HPC systems and storage solutions and leads strategic projects with the center. And she's held different roles at CSCS, including group leads of future systems, chief architect, and head of operations. So as you can see here, her expertise are supercomputing, cloud, and edge security models convergence. So sorry, this is today's title will be supercomputing, cloud, and edge security models convergence using APIs and container technologies. Okay, so I'm going to stop sharing my screen so that Sadaf can share her screen. And,
thanks, Rio. Thanks for the introduction, and thanks for the invite to present. Thanks everyone for attending the talk. So before I start, you can't take it for granted that what I see is what you are supposed to see. So do you see my presentation screen?
Yes.
Okay, so we are good. First step last. Yeah, so I am in no way close to even knowledgeable when it comes to security and edge type of compute, but this is something I would really try to sort of give a message. This is one of the convergence. In fact, I consider it as one of the most important convergence point if you want to get these workflows going across these technologies. So just as a reminder, there is a full version of this talk that was presented earlier this year. Here is the title, and I uploaded the slide to Polybox, so it's downloadable, which is like a Dropbox at ETH Zurich. So what is quickly Swiss National Supercomputing Center? We provide supercomputing services to the research communities in Switzerland and beyond. So this is our flagship system. In addition, we provide services and platform for the numerical weather forecasting to MeteoSwiss. We also provide large-scale data and storage programs for Swiss researchers, as well as being a national supercomputing center. There are some institutions that use, you can almost call it facility as a service, like power, cooling, and space. So I start here, as I said, in this community, the role of the developer is the key. In fact, I would say otherwise hardware is kind of a metal. And for the most part, what we would like to support autonomous building and testing. And in the operating environment where we come from, like supercomputing center in this case, we would like to ensure that the deployment is secure on our infrastructure and meet its constraints. Like for supercomputing or HPC, the constraint is power, performance, and scaling. And then, apps and data is shipped to this environment. So as a very generic setup, our developer is building in packaging environment. I use container just because I wanted to make a point, but it doesn't have to be. And then they are deployed to some trusted place and then uploaded and translated on the other hand. And container technology has becoming one of the most widely used, packaging and distribution technologies for software. things can go wrong everywhere, as this article has described, that the software supply chains attacks are becoming very common, and most of us who work on open source project, I think this is a good article to read. So what we are doing at CSCS, we are to ensure that the software can be built autonomously and deployed almost seamlessly to meet constraints. We are working from key technologies. So one is this RESTful and secure API with cloud native protocols for HPC, the runtime engine for HPC, as well as infrastructure as code for HPC. So all these are very much cloud native technologies. And I like using this picture because in the physical world things go wrong. Things can both intentionally and unintentionally, and they can indeed go wrong in the software world. So due to various attacks, there were some legislative orders that came out, especially in the US. And what does it mean for us? If we look at from the development community, we can expect some sense of standardization or enforcement coming from that. And we would like supercomputing, at least in my case, I would like supercomputing to be as part of it and not be treated as an air-gapped system that is discrete or separate. So there are elements of building trust and transparency on both sides as we use a lot of digital infrastructure. Another thing that is highlighted here, that this digital infrastructure is decentralized. We decentralize operating environment. So we need to really look at our supercomputing ecosystems, isolated air-gapped solution, but really part of the ecosystem. How do we get there? We built identity and access models based on zero trust. I know it sounds totally counterproductive, but I will try to motivate it a little bit why we need to do it in supercomputing world, as well as we will use more and more application as well as other elements of software that is built in open source. And if we rely on tools to deploy them in our infrastructure, that we have to then comply with some standardization or legislative order, we better be ready and compliant. We can't be too spatial in supercomputing. So I bring this picture again with the same motivation, but now I will show something that hopefully anyone in the developer community can relate to, even if you do not use high performance computing. And these are the standard set of tools, at least in CSCS, but I would argue in other environment, we should support natively because they are the tools that help developers to deploy things autonomously, run their continuous integration, continuous delivery pipeline. And it can happen from application software stack to the system software stack due to some of the compliance issues coming in. When it comes to zero trust, I think the picture here, again, it can't go in deep, but the way you need to look at it is that the trust is not perimeter based or implicit. Like once you establish a trust with an entity, you need to reestablish it based on certain parameters. So there are policy decision and enforcement points that ensure that when you go to a resource, whether it's system, is data, is applications, and anything else digital, those attributes and roles play a role in terms of establishing, can you use this thing in this scenario? And this is much more fine-grained. And by doing that, we could really detect earlier. Like in the previous picture I showed, in security, the weakest link is the one where things break. But in this case, we can detect, resolve, and make sure the rest of the supply chain is good. And we can't do it alone on the platform side. So I think we need everyone together to really adopt some of these changes. But it is not easy. And there are 7 tenets that are defined in this NIST document about zero trust. And the reason it's difficult is this changing mindset. So people who are really today building especially in the cloud environment, they have a certain mindset, which we do not typically have for HPC. I can say it's from an infrastructure provider, but I would say with a level of confidence also at the application developer. So as an infrastructure level, we are introducing these two things quite actively: infrastructure as a code, which is a way to deploy infrastructure as software. And CSCS new systems called ALPS has been built with this thing in mind, where you could deploy physical bare metal cluster, but as a software configuration. And same for the API and container, which in the interest of time, I won't go into, but this is supposed to be a teaser, so I'm pretty sure you will get there. Nevertheless, this is work in progress, and it's really hard to change mindset. It is not about a single, silver bullet or technology that would solve it for us. And at CSCS, we are defining them as like this rainbow principles. What are the targets we are focusing on, so we can more or less, from a developer's perspective, work seamlessly between different technologies. And I'm not reading them here, but in the sense of they go from authorization to multi-tenancy and virtualization without losing, performance and scaling. And this is Sadaf's meter of saying how far we are in different areas, and some areas we are barely touching the surface, and in others we are, I think, pretty good. There are a few references in there that you can look up to. And this is the beautiful city of Lugano, and our cooling water for the data center comes from Lake Lugano. So with that, I can stop and take any questions.
All right. Thank you so much, Sadaf, for compressing your original keynote talk into such a short presentation. Okay, so I'd like to open for questions. I actually have a question while people think about what to ask. So you mentioned changing the mindset. I think, yes, I would definitely agree that we all need to change our mindset towards more of this new kind of and secure way of computing, closer to the cloud, I guess. But so how much mindset do like the hardware vendors need to change? Like, do we need to change the mindset of Cray, IBM, and Fujitsu to actually make this change, or is it just the mindset of the developers that need to change?
I think this is a good question, and what I really like in your question is you are sort of breaking it down in different layers, because it's about layering. We look at the layers. It is not one individual, one technology, or one person. So I start with the lowest one, where I feel most comfortable, which is hardware. If we look at the hardware, we are not deploying any special hardware. If you look at the servers, if you look at the GPUs, if you look at the networking, okay, Cray has some proprietary, or HPE has proprietary networking. Yes, so those things should natively support some of these virtualization technology, or some things that we need extra for security. So there is some changes need to be there, but that is, for me, by far is not the blocker or blocking factor. The issues come the way above, in the sense that I can go to, for instance, a cloud company and create a cluster with using a software configuration and deploy it in the way with who can access. I can change my Slurm queues and policies. When I come to an HPC center, everyone has to follow the same regiment or regime, and any changes there could take months or years or never. And then when we bring these different type of workloads, such as machine learning and data science, which have slightly different, access and resource management requirements or storage requirements, we can't reprogram it. So in case of HPE, they are coming up with some technology but we need to do it, but we need investment, because the cloud technologies we can leverage, but you lose a lot of performance and scaling in the sense. But there are, like, containers, for instance, is one of the nicest example, which of course we still have some ways to go to deploy it. And same goes, I think, on the level of middleware and applications. And the challenges will look different. So I do not feel comfortable talking about what those are. But for instance, to begin with, in your software packaging CI/CD pipelines, you can start using some of those practices. I think as a starting point. And then on the infrastructure side, we manage the separation of concern. So it is same as deploying it on your laptop, VM, as well as an HPC center.
Oh, I see a hand raised. Michael?
Yes, I would like to follow up on what you just mentioned in kind of software and continuous integration and so on. I mean, people often have their software hosted on GitHub or some other repository. So how would be your path to kind of integrate them to the world of the supercomputing center? I mean, where you have the CI maybe running on the supercomputing hardware in the center. So is that something that is already offered as a service or partial service at CSDS?
Yes, so I can sort of say it in the thing. So we have a CI service on PISDINT, for instance, but it is limited because PISDINT has not been designed as an infrastructure code environment. So for instance, I can't run a Slurm cluster and a Kubernetes cluster on PISDINT side by side. On Alps, I can. So our idea right now, and this is work in progress, so it's very early, so some of my colleagues will report that. So for some of the CI/CD pipelines where you are not doing at scale testing, I think the more native environment, there will be some Kubernetes cluster with the same hardware running and testing these things. Someone will still have to pay for the usage of resources, but it is both from the resource usage and identity and access management usage. This is a much better model. So we are not trying to fit the native CI/CD pipeline to its Slurm type of environment like that. And by doing this thing, we are looking at it. So our idea is to really create a build service to run CI/CD pipelines. Yeah. And then, of course, at scale testing that should and must go through Slurm environment. Yeah.
Thanks.
Yep. There is a question posted on the Zoom chat by Muhib. So how long do you think users will start enjoying the benefits of the technology? Secondly, what sort of attitudinal changes does it require, and what has been the perception thus far?
Okay. Thanks for the question. And so how long do you think users will start enjoying the benefit? I think now is good. I would like it to be yesterday. I know Luis is smiling, but I think anyone who is doing application software development would then have these established pipelines. I know my colleagues, they dread going to the step of deploying things on supercomputer. Yeah, so now is better, but it should be so. And we, like I said, the CI part is done. I don't know supercomputing centers in terms of where they are offering these things. We need to check, but I would propose you all ask for it. And if something is technically not feasible, then you can say, no, it is. You just need to build your systems differently. Okay, what sort of additional attitudinal changes? So it's difficult, it's hard. And I think I can say me and some of my colleagues, we have scars to show going into this battlefield with our system side of people. But it is on both sides. So I think the first thing we need to maybe stop some of our prejudices that if you do virtualize, you lose performance. And I would strongly encourage people to to say how they are establishing their baselines to begin with, especially their operational workflows. Are you using the given resource to its full potential or not, and how much you are then going to use? So I would really ask people to really do a bit of reflection on where we are today, just like a status check in terms of on the application side, I would really start thinking, if someone isn't using these cloud native DevOps of pipeline, just reflect in your case, if you are a single developer team, I know it's oxymoron, you may not need it, but as soon as you go from 1 to 2, 2 to 4, team, are you using the right tools for right productivity gains and other things? So to me, these are really very, very small. So I would really define them. What makes your team productive? Then what makes your coding productive on any given environment? And it may come with some overhead in some cases, but then you are the one deciding to make that change.
Okay. Any other questions? You don't see any hands raised.
I could
yes.
Maybe just butt in. I think there are two aspects here. So one is the question of software portability, and the other is of software quality. So for instance, I see that yes, we can install a nice module system on a supercomputer and provide that, and everything will be optimized and run well. So for many applications, that's a good idea. But then I also see that we have users who come with very complex software dependencies that only run on Ubuntu or whatever. And in that case, I'm considering asking them to make a singularity container, for instance. Go from there, just use our MPI maybe. So I think both have their virtues, both approaches. What I see as a problem, so we have, for instance, users that use Anaconda to install a huge amount of software locally. And I think that one also should take into account that takes a lot of disk storage, right? I mean, and it's also like they start transferring back and forth these huge environments and so on. So this is something that really comes from the software engineering community or the Python community, and it's not maybe ideal on a supercomputer if everyone has their own environment with a full, basically an operating system installed locally. So but I don't know.
Yeah, no, but I see, and I'm sorry I have to leave, but I can answer offline. With the constraints, you are saying that we need to communicate those constraints openly, because if an application developer only is deploying on a local environment, so be it, you can do whatever. But if they are building in an edge environment, they will run into different constraints. They will not have, gigabytes, tens of gigabytes of, environment to upload. So I think this is really a critical point, that the constraints you mentioned are important. Some constraints may be more strict or not so strict, but the developer community needs to understand those constraints, because we, as you said, in HPC, we bring those constraints because, okay, sometimes not all of them are valid, but because we want to ensure performance and scaling. And if a developer or a user cares about that, then they need to work extra hard. HPC is never going to be free lunch. Sorry, I need to leave now, but bye-bye.
Thank you.
All right. Thank you, Sadaf.